Hello friends. So in this particular subject, kinematics of machines, today we are going to learn about velocity and acceleration analysis by graphical method. And in graphical method, one type of method is relative velocity method, which I am going to cover in this particular presentation. And here we are going to learn about this method by solving one problem, which is a 4-bar mechanism. So this is the problem statement which we have. There is a 4-bar mechanism which has been given with all of its length, AD, AB, all the links have been mentioned, and the crank AB's angular acceleration is also given, which is 10.5 radians per second, and its retardation, that means its acceleration is acting in reverse direction, which has been also mentioned, 26 radians per second. The link is moving with a in counterclockwise direction with angular velocity of 10.5, and the acceleration is acting in other direction, and its value is 26 radians per second squared. And what we have to find out is the angular velocity of acceleration of BC and CD. Not only that, we have to find out the linear acceleration of point E, F, and G. So that is the problem. And the solution involves three steps: drawing configuration diagram, drawing velocity diagram, and drawing acceleration diagram. So for configuration diagram, I should have this draft diagram which has been mentioned in the problem statement. So here, if you see in configuration diagram, what I am going to do is I am going to draw the same diagram to the scale, either reduced scale or to the actual scale, because this will act as a reference for drawing velocity and acceleration diagram. So I have to draw configuration diagram, and if you see this mechanism, the longest link is 100 mm, and if I go for 1:1 scale, I need to consider 100 mm as 1 centimeter, and I have to draw 10 centimeter line, and 10 centimeter line will be very long. It consumes a lot of space in your A4 or normal book which you use to practice, and hence the best thing is go for reduced scale, and I am going to reduce it to half. That means I am going to use 1:2 scale. I am going to consider 100 mm as 5 centimeters. So the scale is 1 centimeter is equal to 20 mm. So 5 centimeter is 100 mm. So I draw a horizontal line AD of length 5 centimeter like this. I have drawn a line of length 5 centimeter which is horizontal. Now for the second link AB, I know its orientation is 60 degree and its length is 15. When you reduce to your scale, it becomes 25 mm. So use protractor, place it on point A, mark a line of 60 degree, and draw a line AB of length 2.5 centimeters like this. So I have drawn a link AB by placing protractor and measuring its length as 2.5 centimeter. Now I need to find out point C, or I need to locate point C in this configuration diagram, and its distance from B and D is known to us. C is at a distance of 66 mm from B, C is at a distance of 56 mm from D. So radius scale will be 33 mm and 28 mm respectively. So use divider, set it to 33 mm, place it on point B, draw an arc of 33 mm. Again use divider, set it to 28 mm, place it on D, draw an arc of 28 mm, and the point of coincidence of these two will be point C, like this. Join the line BC and DC. So that completes the 4-bar mechanism, and there are other points also like F and G and E which you have to show. So you follow the same procedure. For F, the distance from B and C are given. Use the arc method, identify F or locate F. Similarly, locate G and complete the diagram like this. I had drawn F, and so that completes the configuration diagram. Next, I need to go for velocity diagram. And for velocity diagram, I already know the angular velocity of link AB. The angular velocity of link AB is 10.5 radians per second. One more thing which has been mentioned is it is acting counter clockwise direction. It is acting in counter clockwise direction. So using this angular velocity of link AB, I can calculate tangential velocity at point B by using this formula. The tangential velocity at point B is product of length of this AB, which is RAB, and angular velocity, which is omega AB. So the length is 50 mm, angular velocity is 10.5. I got 525 mm per second, which I converted to and sin it, and the answer is 0.525 meters per second. So this is VAB. So first thing, I need to draw this VAB in velocity diagram. I know its magnitude and I know its direction. The tangential velocity VAB acts at point B and it acts perpendicular to link AB. Always remember that tangential velocities will act perpendicular to the links. So if you see the magnitude is 0.525 meter per second, so it will be better to take a scale as 0.1 meter per second is equal to 1 centimeter. That's what I have done, and draw a line perpendicular to link AB like this. I have drawn a rough line first, which is perpendicular to AB, and on this line, mark 2 points A and B, which are 5.25 centimeter apart, like this. So 5.25 centimeter apart. So that's what I have done. And please see here how I have shown the arrow mark. B is rotating in counterclockwise direction, means B will be moving in this upward direction. So that's why I have to show the arrow mark like this. If it is moving in clockwise direction, B will be coming downwards, and then the arrow mark will get reversed. Since it is moving counterclockwise direction, I have to show the direction upward. Next thing is, for point C, if you want to find out the tangential velocity of point C with respect to B, it will act perpendicular to the link BC. And for the same point, if you want to find its tangential velocity with respect to B, it will be perpendicular to D. But I don't know what are the tangential velocity of point C with respect to B and C as of now. But I know the direction. Simply draw a line perpendicular to BC from B and draw a line perpendicular to CD from D, and they will intersect at certain point. That point of intersection is nothing but point C, like this. So this is the line perpendicular to CD, and one more line. This is the line perpendicular to BC, and this point of intersection is nothing but C. Now you complete the velocity diagram. Please do see the arrow marks again. Always you should point the arrow mark such that it should be moving away from the fixed point. So O is fixed point and it represents all the fixed points in the mechanism. It represents A also and D also, because both are, these are stationary, they are fixed. So AD is represented by O, and vector OC is given arrow mark at point O. Similarly, I am finding the velocity at C, so that's why BC is marked like this. Now you measure BC and DC or OC, you will get the VBC and VDC when you convert them to actual scale. So VBC is of 3.4 centimeter, multiplied to the scale we have, we got the answer as 0.34 meters per second. VDC is 3.9 centimeter, multiplied to the scale which we have, I got the answer as 0.39 meter per second. When you practice this problem, you may not get the same answer, but it should be near to this value. You may get it as 0.32, you may get it as 0.33, or you may get it as 0.38. So you may not get the same answers, but please remember that the answer should be near to this one. So we are done with velocity diagram. Next thing is, I need to draw acceleration diagram. For acceleration diagram, what I have is the angular acceleration or retardation of the link AB is given. It is 26 radians per second square, and that will be acting in clockwise direction. Because velocity is acting in counterclockwise direction, retardation will be acting in its opposite to that, so that's why it will be acting in counterclockwise direction. And every link will be having two types of acceleration. One is radial acceleration, another one is tangential acceleration. So radial acceleration acts along the link, tangential acceleration acts perpendicular to the link. So it will be better to consider a table where I can show both these components for each link. So I had drawn this table where I have represented all link except the fixed one. The main links only I have represented. If in this 4-bar mechanism, AB, BC, CD and DA are main links, and I have not considered AD because it is fixed one. I have shown AB, BC and CD links. Their length have been mentioned, their velocity have been mentioned. Length is given in the problem statement. Velocity we just calculated. VAB, VBC, VDC, we have calculated the same thing I have mentioned here. Now, radial velocity or radial component of acceleration is expressed as v square upon bar. That is nothing but this column square divided by r. So 0.525 square divided by 0.05 gives me the radial component of link AB. Similarly, I have calculated the radial component of acceleration for BC and CD. That's fine. Now, tangential component of acceleration AT is given as r into alpha. For AB, I have alpha as 26 radians per second and its length is 0.05. So 0.05 into 26 gives me 1.3 meter per second square. So that's what I have calculated. But for BC and CD, I cannot calculate those values. Why? I don't have alpha BC and alpha CD. Perhaps those are the values which I need to determine. If you read the problem statement, what has been asked is you have to find out alpha BC and alpha CD. So for that reason, I cannot. These values are unknown to me. But what I know is these vectors will be acting perpendicular to link BC and CD. That much I know. So, and this much data is more than sufficient to draw acceleration diagram. So let us start with link AB. First draw the radial component which is acting along the link length AB. So draw a line parallel to AB, and I am going to take the scale as 1 centimeter equal to 1 meter per second square, because if you see the values here, it will be appropriate. So I have taken 1 centimeter as 1 meter per second square. So draw a line parallel to AB. This red line is a line parallel to AB, and on this line mark 2 points which are 5.5 centimeter apart and draw vector A dash. So this is fixed point O, which represents A, D and all the fixed points. So I have drawn A dash. Please remember, this is not A, B, it is A dash. It only represents the radial component of link AB. So A dash I drawn, its length is 5.5. Now perpendicular to this, I have to draw the second vector, that is 1.3 centimeter, the tangential component of acceleration. So that's what I have done. I have drawn a rough line perpendicular to this, and on that line I have marked a length of 1.3 centimeter. Please see the arrow once again here. For this one, you have to consider clockwise direction because it is a retardation and it is acting in clockwise direction. Here, counterclockwise direction is considered because it is acting in uh, upward direction, and here we have to consider the clockwise direction. Now complete the polygon. So this OB, this point of intersection, is nothing but B. OB is the resultant of OA dash and A dash B, and this is the net acceleration of link AB. Now for BC and CD, we know one value and we don't have the other value. So let us draw the known values first. Draw a line parallel to BC of 1.75 centimeter length. So I have drawn a line parallel to BC first, and on that line I have marked 2 points B dash, which are 1.75 centimeter apart. Now, similarly for CD, draw a line parallel to CD, which is of length 2.7 centimeter, and its length you have to show OD dash or DD dash I have drawn. It is parallel to CD and its length is 2.7. Now, for these two, I don't have magnitude, but I know the direction. So simply draw lines perpendicular to the earlier one, BB dash and OD dash. They will intersect at certain point, and that point of intersection is the common point between these two, that is point C. So that's what I have done. I had drawn line parallel to OD dash, perpendicular to OD dash and perpendicular to BB dash, and this point of intersection is C. So I have completed the acceleration diagram, and finally draw the resultant BC and DC. That completes your acceleration diagram. Now, the things which have been asked are alpha BC and alpha CD, and if I have to calculate alpha BC and alpha CD, I need to know this one, and from acceleration diagram we already calculated them. This B dash C and D dash C are the values which should be written here. Actually, initially they were unknowns, but once we completed the acceleration diagram, we found them. B dash C and D dash C are nothing but the values which should be written here, and those values can be used to find out the alpha. AT is known, alpha can be calculated as AT upon R. So B dash G length, if you measure, it is 2.25 centimeter. When you convert it to actual scale, it comes as 2.25 meter per second square. So that is the value which should come here. And if you divide it by R, you will get the alpha. So alpha BC I am getting it as 34.1 radians per second square. Similarly, you try alpha CD, it will come as 79.11 radians per second square. Now, point F, point G, and point E. For these points, I need to calculate the linear accelerations. So I will show it for point G, and similarly you try it for F and point E. Now, if you consider this triangle CGD, CGGD, the same triangle or equivalent of this triangle should be represented on line CD, which is here. So the simplest way what you can do is measure the length of CD and measure the length of this one CD, divide this length by this length, multiply it by CG length and DZ length. You will get the values for this acceleration diagram. Use arc method, find out point G and complete the triangle like this. So that will give you point G, and if you want to measure its acceleration from fixed point, measure OG, and it will give you the linear acceleration. So linear acceleration of point G is dc, which is equal to 3.9 into 1, 3.9 meter per second square. Similarly, for F and E, you calculate AF and AE, you will get the answer. This you try on your own. I have not solved it. You have to try it on your own. In similar way how we have drawn the value for DC. So that's the end of this problem. We have calculated all the unknown values which have been asked in the problem statement. This is the problem for your practice. So again, it's a 4-bar mechanism, and which is very easier compared to the earlier problem. Try to solve this. I have mentioned the answer also. Just see whether you are getting the answers which are near to this or not. If you have any questions, please mail us at the mentioned email IDs. Thank you once again.